Hello everybody, my name is Tim Vanderwood and I'm going to be talking about the Eschede Derailment failure analysis. So what was the Eschede Derailment and how and what happened? So a high-speed train derailed near the village of Eschede, Germany, and 101 people were killed and 88 were injured. And it remains the worst high-speed rail disaster in history and the worst accident involving trains in general in Germany's history. As you can see on the left, there's a picture of the crash itself. About 12 train cars were involved. All of them crushed. There were survivors. As it says, 88 were injured. Not everybody died, but it was quite a disaster at the time. And yes, as I said, the worst high-speed rail disaster in history. So why did this accident happen? A fracture in one of the train's rubber-sprung tires caused the accident. Now, a rubber-sprung tire is a type of train wheel that has a rubber outside with a metal inside. So there's a tire on it, just like a normal car tire, except it's not filled with air. It's just pure rubber. And the fracture happened in this tire. So the actual metal part of the wheel never fractured or anything, but the tire fractured. When it fractured at a speed of 250 kilometers an hour, which was within the range it was meant to be run at, so that was not necessarily a problem. And the tire caught underneath the train after it fractured, and it caught on a train a rail switch that switches the train between two different tracks. This caused half the train to go on one track, the other half of the train was on a different track, which is not good. The train derailed and actually hit a bridge pillar, and it collapsed the concrete bridge on top of the train. As you can see in this picture in the back, you can see the bridge collapsed, and you can see multiple train cars even on top of it after it collapsed. And yes, it derailed, hit a bridge, and many people died. So of course there's an investigation into this catastrophe. And so the manufacturers of the tire, of the wheel and the tire, were actually sued, and there was a court hearing, and 13 experts from 5 different countries held testimony so the root cause of this accident could be determined, and whether or not these manufacturers were at fault, or whether this was just sort of a random phenomena, a singular event sort of deal. So stress analysis, material tests, dynamic load tests, finite analysis, and many other tests were conducted to determine the root cause of this. And this happened in 1998, so not all these tests were definitely what we have today, but they're still definitely well suited to take on this task. So what caused this failure? What did the investigations lead to? What was the conclusion? So a fatigue crack was in one of the tires was found, or the tire that fractured was found. The crack had actually reached 80% depth of the tire's cross-section before final fracture, meaning only 20% of the cross-section remained before it fractured, which is pretty incredible if you think about it. That's much less than half of the tire cross-section before it fractured. So final fracture was at a relatively low mean stress level. Of course it was, because only 20% of the cross-section remained. You don't need too much stress to break it at that point. But the source of the crack is still unknown, and it's actually considered a singular event. And a lot of these studies basically concluded that there wasn't anything wrong with this tire, and that it was just happened to be maybe just the right stress at the right time. There was crack growth, but the material was solid. There weren't any deformities or inconsistencies within the material, and all of the code was up to standard. And the loads that what it was allowed to carry seemed to be should be able to carry that load according to these tests. And so yeah, it's considered like a singular event and a phenomena that this actually even happened in the first place. How was this failure fixed? Well, after extensive analysis of loading and possible methods of fracture, as I said, no prominent reason for the crack resulted. Of course, anyway, many rubber-sprung wheels were taken out of commission, but none had fatal flaws. Actually, 200 were taken out of commission, and none of them had any cracks at all, which was surprising, even after a major failure like this. Later, 5,000 more were taken out just over the course of how these tires' lifetimes, and cracks were found, but nothing fatal, nothing that would lead to a disaster like this one. And as a result of this, none of the manufacturers were ever charged with negligent homicide. As a result of the court case, the jury decided that this really was a phenomena, and this wasn't necessarily anybody's fault. That being said, there are a couple different design improvements that could be used for these tires, and one that I came up with was, since these cracks seem to be sort of random and not for necessarily obvious reason, to mandate a tire replacement every 3 to 5 years to just prevent crack growth. A lot of these studies found that there really wasn't anything wrong with the speed they were moving at or the loading that was on them. So I think maybe the best course of action would to be just monitor the crack growth and replace them every 3 to 5 years, because they seem to happen and they don't seem to happen for a specific reason. This is the end of my presentation, and thank you for listening and watching.